In this video, we're going to look at finding roots or zeros of quadratics when a equals 1. And when we talk about when a equals 1, we're talking about the standard form of the quadratic ax squared plus bx plus c, where this a is 1, so there's not going to be a coefficient. So it's going to be ax squared, just x squared plus bx plus c, where b and c could be different numbers. We're looking at integers for this particular lesson. And what we're really talking about here is, let me just draw an xy axis here. When we get a parabola, alright, so quadratics we know are parabolas, and they look something like this. What we mean by a root or a zero, we mean the point right here where they hit the x-axis. Alright, and if you think about when we're on the x-axis, y equals 0 all the way on this x-axis. So what we're really doing is figuring out what is x going to be when y equals 0. And with parabolas, remember parabolas are they're symmetric. So typically there are two different zeros or two different roots. Now, it is entirely possible that there are 0 roots for quadratics, and it's possible for there to be just one. For example, if we have our x and y axis, and say our parabola looks like this, where the maximum occurs below the x-axis, there's no way that this is going to hit the x-axis. So y will not possibly equal 0. So in that case, there would be 0 roots. It could also be where, and this is going to be difficult to draw on here, so we just might have to pretend something like this, where the parabola just hits in one spot and one spot only. Alright, that would be there being only one root or 0. Now everything we're going to be looking at today is going to have two roots. And a really important concept here for this lesson is, let's say I have two letters or two variables which represent numbers. We're just going to call them m and n. What if I multiply m and n and I get 0? Well, there's three things that could happen here. Either m has to equal 0, or n has to equal 0, or both. M and equals 0 and n equals 0. And that's really the only way that we can multiply two numbers and get 0. So this idea of finding roots, or when something equals 0, we're going to be looking at the product of two numbers equaling 0, and the only way that that's possible is if one or both of them equals 0. And we've actually looked at this earlier on in the year. We talked about factoring quadratics. That's exactly what we're looking at now. That was one of the very first things that we did on Study Island, if you recall. So we're going to revisit that because now we're getting to parabolas and quadratics. So we're going to see where that actually comes into play here. So in order to do this, I'm going to bring up some problems for us to look at, and that'll help you with your ALEKS assignment. Here is our first example. We're keeping everything positive here to make this a little bit easier. So if you remember the FOIL method, when we had a set of binomials, something like x plus 5 times x plus 6, foiling this meant that we would take the product of the first terms. So let me try to color code this here. So x times x would be x squared. And then we would take the outer terms. So we would take x times 6, which would be a positive 6x. And then we would take the inner terms, which would be 5 and x, which would give us a positive 5x. And then we would take the last terms, which were 5 and 6, multiplying them together, we would get 30. Alright, so adding the like terms in the middle, the OI terms I like to call them, we get x squared plus 11x plus 30. All right, so the FOIL method is kind of what we're looking at here, except we're going in reverse. So we're trying to figure out how can we take this trinomial, which you'll notice is exactly what I came up with, not by coincidence. We're trying to take that FOIL method but go backwards and get this product of binomials here, x plus 5 and x plus 6, except this example uses v's. All right, so that's going to be the first step. And I'm going to walk through once again how we do that. So if you remember, when we have ax squared plus bx plus c, we don't have the a here. So all we're looking at is we need to find factors of c, so in this case of 30, that have a sum of b. Because if you remember, the last term ended up being two things that multiplied together to give us that 30. And then the middle terms, the o and the I, they added together since they were like terms to give us the 11. So that's why they have to be factors of c that add up to b. All right, and maybe I'll go ahead and type that in here real quick, just so we kind of remember this is what we're going to be doing the entire time through this. So let me put this right in here. Find factors, and I'll make it a little bit larger so we can see it moving forward. Find factors of c that have a sum of b. So we're going to go ahead and make this a little bit larger so we can see it. Let's even change colors of it so it kind of stands out so we know what we're looking at the whole time. Alright, so we are going to be finding factors of b, or factors of c that add up to b here. So I'm going to walk through this step by step so you know exactly where I'm coming from. In terms of factors of c, there are a lot of these. Remembering that 1 and a number is always its factor. So factors of 30, I guess it should be clear what we're talking about. Factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6, and that's all we have. Alright, and then we talk about adding these together. Now I started off with the positives because these are pretty simple. Add 1 and 30 together, so the sums of these are 31, 17, 13, and 11. And because we're looking for 11, that's why 5 and 6 are going to be our answers here. Alright, but we're not done now. So we know that v plus 5 and v plus 6 can multiply together to equal 0. I haven't talked about it at all yet during this problem, but we can't forget that this is all equal to 0. And what we're going to remember is the only time we can multiply two things and get 0 is if m equals 0, or in this case, v plus 5 equals 0, or if v plus 6 equals 0, or both. So when we're doing these problems, we have to consider both v plus 5 or v plus 6 equals 0. And this is simple. It's a one-step equation. Subtract 5 from both sides. So v could either equal negative 5, or when we subtract 6 from the other equation, v could equal negative 6. So when we're thinking about our parabola here, our parabola is going to be over here, kind of like this. So this vertex, or this root, sorry, the root is going to be at negative 6 and at negative 5. And you can imagine, everything being symmetrical, the vertex is actually going to be right in the middle of them at negative 5.5. Alright, and then you could figure out what that's going to be if need be. But the main part of this lesson is identifying these roots, negative 5 and negative 6. Alright, so let's go ahead and look at another one here. Let's get rid of this one. I got another one waiting to come up here. Let's see what we got here. All right. So we're using the same approach where we're looking for factors of 12 that add up to -7. But this time we have to realize that our product is 12, but when we add these up, we need to get a negative number. And the only way for this to happen is if both factors are negative here. Because since this is positive, the only way for that to happen is for two positives or two negatives. But since the sum is going to be negative, we need just negative factors of 12. So we have -1 and -12, -2 and -6, -3 and -4. So this will give us a sum of -13. That's no good. This will give us a sum of -8. That's no good. This will give us a sum of -7. That's the one we're looking for. All right. And when you get good at this, you don't need to write down all of the factors and sums. You can kind of think in your head what that's going to be. So -3 and -4 are our factors that are going to multiply to give us +12, but add up to give us -7 at the same time. So now we're looking at x minus 3 and x minus 4. And notice this time, this is y equals. So this is the actual equation. But when they say, once again, find the roots or find the zeros, and we talked about earlier, what this means is, when does that graph hit the x-axis? And it hits the x-axis when y equals 0. So what we're going to do is, instead of having y, we're going to say, oh, we want y to equal 0, so let's go ahead and put a 0 in here. So it's still the same idea. We're still looking at when does x minus 3 equal 0, or when does x minus 4 equal 0, and just solve these. So this time we're adding 3, and you can do this in your head. You don't need to do this step. I'm just trying to be thorough here and show you exactly where everything is coming from. So our answers here, or our roots, are x equals 3 and x equals 4. And once again, when we're thinking about the parabola, all right, first of all, we know this is going to open up because it's positive, but our roots now are at 3 and 4, so it would look something like this with a vertex at 3.5. Now, graphing is not a thing just yet, but this is a step in helping us graph these things. All right, let's move on to the next problem. This problem, we'll notice that the c is negative. And the only way that we can multiply two numbers to get a negative is if one is positive and one is negative. So that's what we have to consider when we're looking at these. Now, the other thing to look at is b is positive. So we also have to consider the rules for adding integers. So when we add two numbers together, we have to use the sign of the larger number because we moved farther in that direction than the other. So if we're thinking on a number line of where 0 is, if we go negative farther than we go positive, we're going to be on the left-hand side of the 0 and make it negative. So when we're looking at our factors of 24, which is going to be a lot of them this time, we're going to make sure that the larger factor is the positive one. So we could have -1 and positive 24. We could have -2 and positive 12, -3 and positive 8, -4 and positive 6. And we are looking for the one that is adding up to give us 12. And in that case, it's -12, or -2 and 12 in this case. So we're going to be looking at x minus 2 times x plus 12. And don't forget, even though it says y, we know we want to know when y equals 0. So we're going to set this equal to 0. I'm going to start skipping steps here. We know that we're going to have to add 2. We know that we're going to have to subtract 12 from 0. So our answer is just +2 or -12. And one thing I also forgot to point out is when they say that if there's more than one 0, separate them with commas. So when you put them into Alex for your answer, make sure that you put 2, -12. That's what they're going to be looking at. All right, so one more example. Just like what we just did, except the b in this case is negative. So you can imagine it's going to be the exact opposite. We still have a positive, or I'm sorry, we still have a negative c, which means something has to be positive and negative in terms of the factors. But in this case, the b is negative, so the larger number has to be negative. So when we're looking at factors of negative 30, we're going to have 1 or negative 30, because a larger number has to be negative, 2 or negative 15, 3 or negative 10, or 5 or negative 6, and the two that add together to give us negative 1 is 5 and negative 6. So we're going to have v plus 5 or v minus 6 equals 0. And once again, we know that we would be subtracting 5, so we're going to have v either equals negative 5 or v equals positive 6 for our zeros here. All right. So your assignment is on Alex. It's called Finding Roots of Quadratics. It's 10 questions, similar to what we looked at. Really, you just have to keep in mind, what factors are you looking for? Do they both need to be positive? Do they both need to be negative? Or when they're one of each, which one has to be larger? And that is determined by the signs of B and C. And as always, Zoom or email me if you need help. Zoom is really the best way to do this. If you ask anybody that's been in a Zoom session with me, we really look at your questions. You share them with me, and I talk about what you need to do to answer your questions and get them correct and help you moving forward. Good luck.